Alright, this is a sample of quadratic function problem solving. So what we get as a clue is we know this problem is going to involve quadratic functions in some way or another, and that's all we know. So we do have to spend some time, just like any problem, thinking before we start answering the question all of a sudden. So there's a definition. I'll let that finish writing, and I got to read the question. So here what we're dealing with is a hockey team. It plays in an arena, 15,000 seat arena. So currently they're charging $14 for tickets, but they're not selling out the arena. They're only selling 9,500 seats. So they do some research and they find out that if they lower the ticket price by $1, they would have about 1,000 more people attending the event. So what's going on, if I think I understand this correctly, is although they get more people, 1,000 more people for every dollar reduction, they also lose money because they're lowering the price. So there has to be some price where these things cancel each other out and we end up with the highest possible revenue. So that's what I guess is going to be happening here. When I look at part A, it says find a function that models revenue, sure enough, in terms of ticket price. So ticket price is going to be my independent variable. That's the thing that I get to control, and that's going to change the amount of money that I make for sales. So revenue is money received from sales. I don't really know how to write a function, but I do have some information, and so I'm going to play around with this information and see if it guides me onto a path. So I'm going to look for patterns and look for some sort of clues just by messing around and seeing what happens. So first thing I do is I know the current price is $14 and we can sell 9,500 seats. So the revenue at that price, if I sell $14 tickets, 9,500 of those tickets, I will make $133,000 in revenue at that price. So what we can do here is we can now start looking at what that survey says, and the survey says that we lose, or if we lower the price by $1, we'll get 1,000 more spectators, and that should obviously change our revenue. So the ticket price, again, $14, 9,500. If we do 14 minus 1, that's $1 less dollar. We're going to have 1,000 more people, $2 less dollars. That's going to give us 2,000 more people. $3 less dollars, that's going to give us 3,000 more people. Now I didn't figure out the revenue yet because I'm just trying to understand how the sales are affected by the ticket price. But if I wanted to know the revenue, all I would have to do is to take the 10,500, multiply that by $13, and that'll give me a different revenue than what I had over here. I think it would be around $135,000 or something like that, maybe 130, somewhere in there. But it will be different. You can test me on that. But the more important issue here is the pattern that's emerging. You see, if I lower the price $1, I gain 1,000 times 1 more people. $3 gives me 3 times 1,000 more people. So there's this direct and I think linear relationship here. So for every dollar down, sales go up by 1,000. That's a rate of change. So this is the issue now. How can I express sales in terms of whatever price I want? I want to say the price is $3.75. I should be able to develop a formula that would tell me how many people are going to attend based on all this given information. So it's going to start with 9,500. That's my $14 baseline. And then apparently we're going to add 1,000 people, but we're not just adding 1,000 people times the ticket price, because that would be 14,000 people. 14 times 1,000, that's way too many sales. So I have to figure out a way to use my ticket price and only increase the correct amount of thousands of people. So here's what I think is going to work. I'm just going to put this down and hope for the best. I did 14 minus the current ticket price. This kind of makes sense to me because if I charge $14 and then I do 14 minus 14, that's 0 times 1,000 people. If I choose $12 for my ticket price, it's going to be 14 minus 12, that's 2 extra sets of thousands, 2,000 for a $12 ticket, more than the 9,500. So in other words, I just want to make sure I got this right. So if the ticket price is T, my sales are 9,500 plus 1,000 times 14 minus T. Try $10 and see if it works. The $10 ticket price is going to give me $13,500. And what I recognized is that at a $10 price, that gives me 4 sets of price decreases. That's 4,000 more spectators in the stand. That's 13,500 people attending at a $10 ticket price. So I now know that the ticket price that I came up with here, or sorry, the sales that I came up with here is valid, but it's kind of a clunky little equation, so I'm going to use my Algebra 1 skills to simplify this. First thing I'm going to do is distribute the 1,000, and then collect the like terms, as it were, so that we can get a base simple equation. So there's my sales equation. And what I noticed right here is something that I've observed in my exploration. This is a linear function. My sales function is a linear function, and essentially my sales will depend on the ticket price. And we'll have, well, if we could fit this many people in the arena, we'd have 23,500 people, and then we will lose 1,000 people for every dollar I charge. So I could check that this works by, putting in 14 for ticket price, and that would be 23,500 minus 14,000, which would get me back to the 9,500 originally. So, that's sales, but again, this is a linear function. We're studying quadratic functions, and what I'm asked to do is to find revenue in terms of ticket price, not sales in terms of ticket price. So I feel good about my accomplishments, but I'm not done yet. So we got a price, we've got sales, but revenue is what we're looking for. And I remember that if I multiply the ticket price times the number of tickets sold at that price, that'll give me my total revenue. $13, 10,500 people, 13 times 10,500. T dollars, 23,500 minus 1,000 T sales, we should be able to multiply the sales times the ticket price, and that will give us our current revenue. In conclusion, if I distribute the T, I get my revenue function, and notice that is a quadratic function. And so now we can start going all quadratic on this sucker. The hardest part of the problem is coming up with that equation. And once it's quadratic and once you've confirmed that it's correct, the rest of this work should be rudimentary. It should be easy, comparatively speaking. So for example, part A said find the function. Got it. Done. Now I will check this using technology, but I assure you this is in fact the correct equation, and I'll show you at the end of this lesson. Part B was asking what ticket price is so high that that no money is generated. And so what I did is I said, well, if no money is generated, that means we have zero revenue. So I'm basically saying revenue equals my revenue equation, and then we have to find out the ticket price that's going to zero out my revenue. This turns out to be pretty straightforward algebra. It's a quadratic function set equal to 0. I checked to see if it's factorable. Of course it is. You factor out the t that we multiplied in. And then we get two choices, either t equals 0 or 23,500 minus 1,000 t equals 0. The first situation, t equals 0, is not a high price, that's free. And so that's not the answer to my question, what price is so high? Free is not a high price. But over here, I see $23.50, and I'm gathering that $23.50 is going to cause zero revenue as well. So if I'm charging $23.50, there's going to be an empty stadium. No matter how much people love hockey, they're not going to pay that much to see a local hockey team, I'm guessing. All right, so continuing on. The next question is the maximum revenue, and the maximum revenue is, well, it's a quadratic function, so the maximum revenue is essentially going to be at the vertex of the quadratic function. So I remember this formula to find the axis of symmetry, the opposite of b over 2a, and it turns out to be half of the maximum price, which is $23.50. If I charge $11.75, I will have the maximum revenue. The maximum revenue can be calculated at R of $11.75. Now, the question didn't ask for what the maximum revenue is, and I'm assuming that I had to do this without a calculator, so I accept that this is the best answer, and this is just one step further. But since I have the technology, I'm going to Desmos this graph, or this function, I put the function into Desmos and I graphed it, and once I found the key points indicators here, I see zero revenue for $0. That makes sense. 23.50 gives me zero revenue as well. That's consistent with the work that I did. $11.75 maximum revenue, and now I also have $138,000 in extra 63 bonus in sales for charging $11.75. To further demonstrate how I know this is correct, when I had a ticket price of $14, if you remember at the beginning of the video, we calculated $133,000 in revenue. And at 10, I had $135,000 in revenue, and I can see, according to my table, that that is indeed correct, and these are those 2 points right here. Not the maximum revenue, but pretty close either way. And so, now, just before you give up on math altogether and stop trying, realize that I did this example with the most challenging kind of quadratic functions problem available. This part right here that I set up in the beginning, this is going to give people the biggest challenge. It seems complicated. It's really not. You just have to be, calm and patient and methodical. Think while you work. Look for patterns, and the patterns will emerge. You'll get better at this the more you do it. So anyway, that's my story. Thanks for watching, and good luck in your learning.